Hello. So, as the title says, this is actually not a tutorial. And in particular, it's a not a tutorial. So, what I mean and what I'm going to be talking about here is something called the microlithic, or what I refer to as the microlithic form of GOPE. So, GOPE is goal-oriented action planning. And a very, very, very long time ago, probably nearly a couple of years ago now, I made a video showing what I refer to as the monolithic version. So with the monolithic version, a single action fully completes a goal. It doesn't need multiple actions to complete that goal. And I did mention in that video about the alternative version, which is called microlithic version, which if you've looked into it, done research, is probably the main version you actually sort of have seen. And the idea behind the microlithic version is that you have little sort of Lego block actions, and it pieces together those Lego block actions to achieve the particular goal. And I intended to do a tutorial on this a very long time ago, and I experimented with a lot of different techniques. And in particular, I'm sort of trying different ways of approaching it, and I never found one that I was particularly happy with. In every case, I always ran into the same issue where I'd hit a level of complexity with it where it's a case of I can't in good conscience recommend using this, which is why I never ended up doing a tutorial on it, because in every case I didn't feel that it was an approach that I could recommend as being something that is better or more maintainable or worth the actual higher dev cost there for actually using in a game. So I was at this point with it where the different implementations, I was just sort of not happy with them. And understandably, the questions kept coming up of, hey, when am I going to do the video for this? And a lot of time and a lot of things happened in between. And so I have never really hit a point where I've developed a version that I'm fully happy with. And I will go into more sort of detail on that. And I think sort of really the goal for this video is, and this is why I refer to it as being not a tutorial, is, and I'm going to put the code for this up. This is my implementation of an approach to doing that kind of microlithic GOPE where you've got the multiple actions and you piece it together. Now I want to be very clear that I'm going to give a bit of a run through. I'm not going to give a full tutorial for building it, and the reason for that is that it's still an approach I don't recommend using, but I think there is value in looking at things that don't work out and looking at why they don't work out. I think is actually really valuable. We can learn just as much from our mistakes as we can from our successes. So let's dive on in, and I want to show you what I've actually got set up wise. So this is the environment that I created here, and I wanted to have it that I could really sort of see and get the advantage out of the microlithic GOPE. So I wanted to have a lot of things where there was overlap in the behaviors. So I've got three different types of resources here. I have water, I have wood, and I also have food. I also have three different storages here for the respective type of resource. So the idea is that when a character gets hungry, they could go and they could gather food, or if there's food in the storage here, they could go and retrieve it from there. So two slightly different actions. One was a gather, the other was a withdraw. And then once they're holding food, they could consume it. So set it up like that, and the same worked for thirst. Wood was sort of similar in that it was sort of a fallback one where they could go and collect wood and then they could store that, or they could go and use it to expand storage. So again, everything had that idea of gather from the world or withdraw from storage, and then all of the different actions were split out separately. And if we take a look at the character, we can actually see we've got lots of different goals, and we have lots of different actions, but in no case is the action able to fully satisfy the goal. So satisfy thirst needs to either use a gather or a withdraw for the water resource, and then use a consume. So that was sort of the general setup to really have it as being something that was going to put Gope, this style to the test, and actually be able to also make it really easy for the benefits of it to show through. So let's take a look at how I actually sort of structured this stuff. So I'll zoom in a bit, and the main thing, so the one that does that drives a lot of the work, is this Gope class. So it keeps track of current state. And this is one of the big things with doing the microlithic Gope. You need to have this concept of state. And this is actually where one of my big issues with the actual sort of architecture for the system is that I don't like how that state manipulation has to happen. Because what we have is we have this state, which if we take a look at it, the state has some flags on it, so we can store these different things like, things that we're trying to achieve. So if we're hungry or thirsty, we can store stuff like general sort of state information. So I set these up as flags to make it easy for being able to test individual ones to be in multiple of these states at the same point in time. In hindsight, I don't love this approach. Like, it did make it much quicker for testing what state we're in. But the downside is I've already used quite a lot of bits here to actually represent this. So in a larger scale game, I don't think this would be sustainable. I think this would run into issues. Now, I have intentionally separated things by quite a bit, but still, I think in a larger scale one, it would be quite easy to run out of these flags. I had stuff in the state in terms of location. This flag for if it was dirty, so if it had been recently modified. The current target, and this was something that I found that I had to do, which I'm not, this again is part of why I'm not a fan of the sort of state setup, is I found I needed to have this dictionary because different actions might have different targets. So for example, if something is trying to go and restock wood, its target for the gather action is going to be a tree, but its target for the store action is going to be the storage container. So we needed to be able to keep track of different targets for each action, and knowing the current target was also important. So I set up a couple of things for cloning those states as well and for manipulating them. I did go pretty strict with what I allowed to modify the state, which is why there's a lot of functions here. I did very intentionally make that so it was really, really difficult for anything external to modify it without the clear sort of interfaces. So the actual planning side, there was a couple of things obviously for checking, refreshing priority, checking if we had a better plan to run. It's very similar to what we already have in the monolithic version of Gope. So this is not particularly different. This replan, however, this is where we start to get into the more specific aspects with microlithic one. So when it's building up a plan, so this replan determines essentially what should we be doing right now. So it goes through the goals. It picks the best goal to be trying to be running, and it tries to construct a plan for that. So this plan gets built here. So microlithic Gope works a lot through manipulating state. So the idea is that an action manipulates state. And what we do is we have our current state and we have our desired state, which if we take a look at any of the goals, so if I take a look at a goal like satisfy thirst, it's checking if we're thirsty, and its desired state is that we have consumed water. So then in the actual logic here, what the actions do is, okay, we're at a state where we're thirsty and we want to be in a state where we've consumed water. And so we find actions in between that will build us towards that. It's very similar to pathfinding. And it kind of is a very simplified pathfind. So the way I structured this was I identified first kind of the terminal actions. So the actions that, if placed at the very end of the plan, would be able to achieve the desired state. So if we take a look at what this does, it looks for if the action can achieve that particular state. So for example, satisfy thirst, if we go to consume, then can achieve, well, it can achieve either consumed food or consumed water. So what I would do is I found those terminal actions first, because that gave me essentially anchor points at the end of the plan, and I found that really helped of getting those anchor points and then going from there. So what I would do is it would then go and after it's found those terminal actions, then builds up this set of candidate actions. So in every case, it's looking at, okay, here's my current state. Can this action run for that? It makes sure that we don't try and run the same action immediately after. I also found the dirty flag one was helpful there, because this calculates state. What I do is I check, okay, can an action run on the current state? And calculate state is essentially doing okay, let's pretend that I have gone and actually run this. So gather is a good example for this. Gather can achieve any of these states. And if we remember, consume required us for it to be able to run, it needs to be holding food or holding water. So gather, if the target state is holding food, then we try and find food and we modify the new state to be that. We do a check down here of did we actually successfully find the target, and if we didn't, we fail out. And we're storing the target here. That's populating that dictionary. So the GOAT planner goes and finds those terminal actions. It then, for our candidate action, so for our current state, it goes and calculates, here is the possible ones that I could add into that, and adds those into the open list as a node. So a node is an action and what that new state would be. So then the planner, once it's gone and added those candidate actions, keeps continuing until it finds a node that achieves that target state. So it'll piece together gather, and then it will piece together the consumption of the water. So it works okay, but this manipulation of the state is one that I'm not a fan of. That's actually one of the things that I think from a performance point of view, I use flags a lot to try and simplify it, but there is a lot of memory churn with this, creating copies of a state, manipulating that. So I don't like that level of memory churn with it. That in particular was something that I was not a fan of. And I just found that it ended up being, having these sort of generic actions. Like I could have split this out further and had, gather food, gather water. But that just, again, it feels like I'm writing a lot more code and creating a lot more files to achieve the goal. So this state management and that sort of duplication, I think, of tests and so forth is one of the things I really wasn't a fan of. Now it works, but what I also did, and this is what I've seen a lot of GOAT methods do that are following the microlithic approach, is the GOAT actions, they do actually have a set of staging that they do. So if I take a look at my base action, then when it gets ticked, the actions do have a position associated with them. And this is what we've found with ones that implement microlithic GOAT. It's very, very, very common to see this. I think every approach I've seen so far has this concept of a location being baked into it. And that's a big part of it is, firstly, the action actually moves into position, and then it performs the action. So you could split that movement, if we were going sort of very strict with an action performs only a single task, then what we would have to do is move that out into a separate thing. But you might have the one plan that requires multiple rounds of moving, so you're reusing an action the same, multiple times in the same plan. So that's why I set up some stuff here for being able to reset actions. So it works, and this split approach is viable. And if I take a look, then it does manage to go and perform its various tasks. And I did modify the debug to show what goal it's trying to do. So they'll restock wood for a while because they're not actually sort of hungry or thirsty yet. But they will hit a point where they then decide, okay, no, I need food or water. And so they've decided to do that. They're heading over to the water now. So it does properly piece together the plans. It does manage to execute them. But the amount of churn, and I find there are ways that I could clean this up with some editor extensions so that it was a little less messy. But there ends up just being a lot of files and a lot of extra code compared to the monolithic version. So that's why I wanted to sort of run through this, is that I think it's useful to show an approach to it. I'm also going to put a link in the comments to a GOAT implementation that was suggested to me, and a big thank you and a shout out to Silicon Orchid for mentioning this. So there is a version of this that I've seen done where what they were doing was running stuff in parallel, so a multi-threaded version, as really cool setup. I haven't sort of seen that kind of way of approaching it, and that would mitigate some of the performance issues with the mutating of state, and they had some really clever setup for it. But it is a lot of infrastructure. It is a very cool approach, and I highly recommend looking at it. If you were dead set on using microlithic GOAT in a project, I would lean more towards using that than I would towards using this code that I'm showing today. So while I will link to this code, and you can see the repository for it, I really don't recommend using it. I don't like the performance for it. I don't like the overhead for actually sort of, doing the planning. I think that's a lot slower as a result of that state manipulation. And it's hard to avoid a lot of that. In particular, there's a lot of duplicating of that state. So we have to, every time we're doing a plan, we have to clone that state. So there's a lot of memory churn there. Now, C#, there are some ways we can minimize that, but it does get a little bit difficult. So that's really one of my big issues with it. So just to sort of, recap kind of the reasons why I still don't recommend microlithic, and in particular don't recommend my implementation here. There is a lot of memory churn with that state manipulation, and that is something where with more AIs would become a bottleneck. And so that's a big issue there with it. I find in terms of general code structure, it can be a little difficult to figure out, okay, what do those little Lego blocks look like? What are our individual Lego block actions? Now, some game styles are going to lend themselves to that easier than others. So strategy, city, sort of village management type ones are going to lend themselves better to that than something that is more heavily, combat focused and is very sort of short-term reactive stuff. So I don't, that reason it ends up, I find, being more difficult to write. I find it's more code, and in general, I think it just is a little bit more difficult to figure out what you should be doing. So the code's available for this, and I do recommend taking a look at the code. You can see how I have approached it. I have, as I said, put a link in the description to that paralleled implementation that Silicon Orchid linked me to. If you were going to be determined to be using microlithic cope in a project, I would lean more towards using that. I would very much not recommend using the approach I've used here. It works, it's functional, you could build further things on it, but it just doesn't doesn't match the performance you would get with monolithic. That said, monolithic also has issues. Monolithic, you do often end up, introduce a new behavior, you have to create new sets of code for it, you can't as easily reuse stuff with that. So that's actually why I'm working on something that I'm trying to get it to sort of sit in between the two of them. So it'll be similar to, closer to the monolithic GOP, but a tighter coupling with state machines, sort of what I'm working on at the moment. And as soon as I've got that available, that is something that I will be linking to folks. But dive on in and experiment with this. Try out setting up different actions, try out sort of different changes you might want to make to this and see how you find it, especially compare it with the monolithic one for what you find works better for you. Because the monolithic one makes a lot more sense for my way of thinking, but that's my way of thinking. That might not be your way of approaching things. So the microlithic one might be something that makes a lot more sense for you, and if so, great. But probably don't use this implementation. Use the other one that I'll link in the description. Thanks, folks. Hope you found the video interesting. And this is obviously the first not a tutorial. So I'd be really interested to hear in the comments below whether this sort of thing is interesting. If seeing sort of examples of where essentially things have gone wrong. Or I've implemented something and hit a point where I'm like, oh no, this is terrible and I won't recommend this. If seeing things like of those mistakes would be helpful, then do mention in the comments, because there's plenty of mistakes that I've done. And I do think there is a lot of value in learning from mistakes, both your own and from others. So do mention those in the comments. If you've got questions, chuck those in as well. And if you are looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description below. But until next time, bye.